we know a translation's a slide, so we're not interested in the definition. I know I'm sliding it, but how do I know that I've done that slide correctly? We're going to pick on a table here to get us a kind of starting idea. Let's see. And we got some people that are gone or have been gone. Madeline. So I know I'm sliding my shape when I translate it, but how do I know I've done it correctly? How do I know I've landed in the right spot with my slide?
It's not flipped. Like with the ant, it wasn't, I guess, like it was the same shape, but it was just moved somewhere else. It wasn't like flipped with like the head facing somewhere else.
Okay. So when you're saying it's not flipped, like it's still facing the same direction? Okay. So really, what Madeline mentioned when she said it's not flipped, she's kind of talking about the orientation of the shape, right? So whatever was in the top left corner of the shape is still the top left corner of the shape. So that's an important thing with the translation. It keeps the same orientation. So you know you did a straight slide. So shape keeps same orientation. Okay, so that gets us an initial idea. Please take your earbuds out. We're not listening to music right now. What else? It kind of opens it up. What other things will help me to know that I've slid my shape correctly? Jacob?
It's like the same sign. It's basically the exact same thing at any location.
Okay. So same size and shape. And really, we could take this and duplicate it for our rotation or reflection because we said that's why these are called rigid transformations, right? They're staying the same. What else should be happening with my translation that'll ensure a correct landing spot? Any other ideas? I'm going to flip this over for a second so I can show you guys something. Get us thinking for a moment here. How about, I'm going to take a couple points here. Okay, so we said it should keep the same shape. So my shape is a line segment, right?
Okay.
Okay. So I'm going to slide it. So I'm going to slide it like this, and then I'm going to slide it like this. So it's still the same orientation. The left point's still on the left, and the right point's still on the right. It's not flipped around. What did I do wrong? Yeah? So what did I do wrong when I was sliding my points that changed it, though? Yeah, so what should be happening to all my points? Parallel. They should all be going the same direction, right? So that was kind of implied with keeping the same size and shape, but I wanted to draw that out a little bit to get you guys thinking about how do I make sure I'm keeping it the same shape. Everything should be sliding the same direction, so those slide lines should be parallel, and that was something that was mentioned yesterday. So all points move the same way. Which means they're going to be moving parallel. That gives us some good ideas for translation, right? What our rotation? So we know when we rotate a shape, we're spinning it. But what do I need to know about a rotation that tells me I'm doing it correctly? Lauren, what did your table come up with?
We said the image would be at a different angle than it was in the beginning, and the image goes around the point of rotation, and the distance from the point of rotation stays the same.
Okay. Yeah, so there are several kind of important things there. Lauren mentioned the point of rotation, and that's really important. Can I spin an image if I don't have a point to spin it around? No, so that's probably the most critical thing of all with the rotation is that I have to have that point of rotation, which we actually call the center of rotation. So it's spinning around a center of rotation. And I'm underlining that because that actually is a vocab term. Mathematically, that point is actually called the center of rotation. So that's really important. Because if I move my center of rotation, so if I put it here and spin, that's going to do one thing. But if I move it over here and spin, that's going to move my shape to a different spot, right? So that's really important. Okay. So that kind of hit, what Lauren said right there, kind of hit on probably the most critical thing about a rotation. When I'm actually spinning the shape, what else do I need to pay attention to? Skylar? Yeah, so the same arc. So I'm going to turn this over for a minute. So if I take, here's my center of rotation. If I take my shape and I spin it, it needs to spin around the same arc. Okay, so it'd be kind of like that, right? That arc is important because, let's say I move my point over here. I connect that, and I connect that. What's going to be going on with these two things? How far apart they are. What about how far apart they are? So like if my point's here, did I do it right? No. How did you immediately know that's wrong?
It's not the right length.
It's not the right length. Yeah, so this length or this distance has to stay the same, right? So that was something that came up yesterday when we were looking at those arcs that were drawn on papers. Yeah, so we're spinning around the center of rotation, but when we do that spin, we should stay the same distance from the center of rotation. And just for fun, I'm going to flip the paper so that I have space to write this. So distance from the center of rotation stays the same. Yesterday we were doing a 90-degree rotation. You really could do any amount you wanted, but the big things are I need to know when I'm spinning around, and I need to pay attention when I'm spinning it so that I'm not making it get too close or making it get farther away, because that's going to affect my rotation if I do that. Okay. So that gives us some ideas for rotation. Let's see what we got for reflection. So what things tell me that I've reflected correctly? Ryan. So Ryan, if I'm doing a reflection, how do I know that my reflection has landed in the correct spot? Okay. Maybe we need some ideas here. Aisha?
So, like the image is opposite of the image?
Yeah. So it's the opposite. So how do I know that I've made it exactly the opposite? Skylar? Yeah. So to show you guys, just to reinforce this, because I know the reflection was kind of the hardest one for a lot of you guys yesterday. I'm going to turn this over. Let's say I'm taking a point. I'm going to take this guy again, my little line segment. And I want to flip it over this line. So a couple of things. Because I think if you guys see it visually, those of you guys that are staring me down will make sense. Is that correct? No. Why not? Okay. Yeah. Because if I connect these, it should be. Oh, yeah. It should be right here, right? Yeah. So I know that I have done it correctly if
It's like the same distance and the line is straight and it makes like a 90-degree angle.
yeah. So there's the 90-degree angles that were mentioned. So that's one property of a reflection, is I know I'm going straight across. So the path that the points follow should be running 90 degrees to the line of reflection. So that would be a good thing to write down. So the path of the points is 90 degrees to the line of reflection. And then the other thing that was mentioned too, because some of you guys were staring me down, I'll show you in just a second after you have a chance to jot that down. I'm going to flip this back over for a second. I'll turn it back over in a minute. Let's go back to this again. Here's my point. So, okay. I have to go straight across. So I'm going to go straight across 90 degrees. So I know I'm going straight across. I went 90 degrees. So that's in the right spot, right? Okay, so this is reinforcing the other big thing that I heard mentioned, which was what? Alex?
The distance from the image to the reflection line.
Yeah. Okay, so both of those things were mentioned, but some of you guys were kind of staring me down, so it was worth a reminder and reinforcement. Yeah, so I have to go straight across, but I also have to stay the same distance from the line. So the points go straight across, and points stay the same distance from the line of reflection. Line of reflection.